In this video, let us continue to solve more problems based on the first principle of mathematical induction. Alright, we've got a problem here which reads like this. It says, using the principle of mathematical induction, prove that 1 times 3 plus 2 times 3 square plus 3 times 3 cube plus plus n times 3 to the power n equals 2n minus 1 times 3 to the power n plus 1 plus 3 the whole divided by 4 for all values of n that belongs to capital N, which is natural numbers. Alright, so as we know, to solve the problems based on the first principle of mathematical induction, what we first do is, we say that let P of n be equal to, or be the statement which says 1 times 3 plus 2 times 3 square plus 3 times 3 cube plus plus n times 3 to the power n equals 2n minus 1 times 3 to the power of n plus 1 plus 3 the whole divided by 4 for all values of n that belongs to natural numbers. So this is how we start off with. And then what we do is we replace n by 1. So we test out this equation if it is valid for n equal to 1. Alright, so now for P of 1, let's see what happens. So for P of 1, now what does this n mean? N means n number of terms. It just keeps going on. For P of 1, we just take the first term. That's all, right? So now 1 times 3 equals 2 times, in the place of n, we substitute by 1. So 2 times 1 is 2. So 2 minus 1 times 3 to the power of n plus 1. If you substitute 1 in the place of n, then it becomes 1 plus 1. So that becomes 3 square, which is, alright, let me write it 3 square. You know why? Because I replace n by 1 and 1 plus 1 is 2, and that's how we get 3 square. Plus 3 divided by 4. So we have 2 minus 1 is 1. 1 times 3 square. 3 square is 9. So 9 times 1 is just 9. 9 plus 3 is 12. And 12 divided by 4 is 3. So here we are. 1 times 3 is 3, which is equal to 3. So we've got that P of 1 is true. So this is the first step in solving a problem based on the first principle of mathematical induction. Alright, so this is the first step. Let me mention it here. So this is the first step. Alright, so now let's go to the second step. The second step, as you know, is nothing but we just have to assume that let P of m, now we've shown that P of 1 is true, but in the second step we assume that let P of m be true. So if P of m is true, then what happens? Then we have nothing but in the place of n we have m. So this is how it's going to be. It will be 1 times 3 plus 2 times 3 square plus 3 times 3 cube plus plus m times 3 to the power m, which is equal to 2, in the place of n it is m. So 2m minus 1 times 3 to the power, in the place of n you replace it by m. So 3 to the power m plus 1 plus 3 the whole divided by 4. So this is how it is when you assume that let P of m be true. So now that we've told let P of m be true, now what we have to do in the third step is we shall show that P of m plus 1 is true. The most important thing here is we are not assuming that P of m plus 1 is going to be true, but we are going to show, or we're going to prove that P of m plus 1 is going to be true. Alright, so since we definitely do not have much space here, let us go to a new page to show that P of m plus 1 is true. So I'll continue here from the third step. So in the third step we shall show that P of m plus 1 is true, and also in the bracket I've just mentioned the problem altogether because, you know, it's not going to be feasible for us to like go back to that page to see what is the problem. So this is what it is. So in this place it is n. We proved it for, we proved that P of 1 is true for this, and we've assumed P of m is true. So in the third step, we're going to show that P of m plus 1 is true for this statement. Alright, so let's see what we have to do now. This is the most important step, by the way. So now all that we have to do is for P of M, we just had this replaced by M, right? So that is one thing. Plus, if you have to introduce another term M plus 1, it definitely have to be after M. So this is how it's going to be. It's going to be 1 times 3 plus 2 times 3 square plus 3 times 3 cube plus dot 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 plus M times 3 to the power M plus the next term obviously is going to be M plus 1, right? So M plus 1 times 3 to the power M plus 1 equal to 2 times, in the place of N, it's going to be M plus 1. So 2 times M plus 1 minus 1, this minus 1. So let us close this with flower brackets, times 3 to the power M plus 1 because N is replaced by M plus 1 plus 3 divided by 4. So now what we are going to do is we are going to just go back to the previous page just for a second to show that we had here, when we assume that P of M is true, we had 1 times 3 plus 2 times 3 square plus 3 times 3 cube plus dot 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 plus M times 3 to the power N. Now this whole part was equal to the right hand side 2M minus 1 times 3 power M plus 1 plus 3 divided by 4. Now what we are going to do in the next sheet is that we are going to replace this entire thing, right? Because this whole thing was equal to this, but in the place of N it was M. So that's what I'm going to do here. So this was equal to 2M minus 1 times 3 to the power M plus 1 plus 3 divided by 4, and then I'm going to continue here, plus M plus 1 times 3 to the power M plus 1. So now solving this, we need to get to this one, right? So that's what we have to do. But in the place of N, it'll be M plus 1. So eventually we have to solve this and get it to this one. So let's see what we do now. From here, it's going to be simple mathematics only. There's no conceptual thing as such. It's just mathematical operations from here. So the first step is I'm going to treat this as a fraction. I'm going to write it divided by 1 so that it becomes a fraction. Take LCM. So what we're going to get is we're going to get 2M minus 1 times 3 to the power M plus 1 plus 3. The LCM of 4 and 1 is 4. So it's going to be plus 4 times M plus 1 times 3 to the power M plus 1, the whole divided by 4, because we've taken the LCM and it's found out to be 4. So now what we are going to do is, if you consider these terms, so say if you consider this term and this term, you can see that 3 to the power M plus 1 is same in both the terms, right? So I'm going to factor out 3 to the power M plus 1. I'm going to take it out as common terms. So take out 3 to the power of M plus 1. You have 2M minus 1 plus, now while I take 4 times M plus 1 here, let me also multiply it. So 4 times M is 4M. 4 into 1 is 4. So here goes this. And then I've got this 3 separately. So I'm going to write it plus 3, the whole divided by 4. So the next step is I'm going to solve inside this bracket. So we have 3 to the power M plus 1 times 2M plus 4M is 6M. And 4 minus 1 is 3. So it's going to be plus 3. And outside we have another plus 3 divided by 4. And if you consider this particular term, 6M plus 3, I can take out 3, right? I can factor 3. So 3 to the power M plus 1. Now times, I'm going to take out 3. So it's going to be 3 times 3 into what gives you 6M? 2M. 3 into 1 gives you 3, right? So plus 3 divided by 4. Now since it is 3M plus 1, 3 to the power of M plus 1 into 3. Now if you remember the rule of indices or the law of indices, if you've got something like, say, 3 to the power of M plus 1, you can write this as 3 to the power M times 3 to the power 1, right? Since the bases are same, you sum up the exponents. So that's exactly what I'm going to do here. Now just 3 is nothing but 3 to the power 1, right? So what I'm going to do is, I'm going to write 3 to the power M plus, now since the bases are same, it's going to be 1 plus 1, which is 2. 3 to the power M plus 2 times 2M plus 1 plus 3 divided by 4. So now it is almost done. So what we have to do is we just have to get it to this form. You just look at this form and all you have to do is just rearrange it. 2n minus 1 is first, right? So just write, it's approximately that one. So 2m plus 1, it's not yet finished. So please be patient till I finish and you'll definitely understand what it is. So 2m plus 1 times 3 to the power m plus 2 plus 3 divided by 4. So we have 4, we have plus 3, we've got almost everything. All that we have to show is n is replaced by m plus 1 is what we have to show. So now, here we write, in the place of n, just go ahead and write m plus 1. So 2m plus 1 minus 1, this is going to be under bigger brackets, times 3 to the power, in the place of n, just write m plus 1. Don't worry about this step, we will come back to this step. So, in the place of n, we have replaced m plus 1, alright, plus 3 divided by 4. Now, how do you think this is equal to this? Well, if you see m plus 2 is written as m plus 1 plus 1, which is m plus 2. And if you check here, we've replaced n by m plus 1, right? But if you solve this, you're going to get back this. How? Because 2 times m is 2m, and 2 into 1 is 2. 2 minus 1 is 1. So here we are. So from this step, you can go to this step. But instead of breaking your head on how to make this like this, simply replace the right-hand side of the question. In the place of n, replace it by m plus 1, and you have the answer. So therefore, P of m plus 1 is shown to be true. So, and that ends this problem as well as this video. So, I'll see you in the forthcoming videos with more problems based on the first principle of mathematical induction.